It's a half.
It's a half. It's the
Whole.
So define a fraction. A fraction is a part of a whole.
Numerator is the portion that is asked and denominator is a whole. Dividing things equally.
dividing things equally. What things?
Miss, suppose a cake, Miss, you cut it to 4 pieces together and you get quarter. That together makes 1.
When we divide something, so that part is called as a fraction.
It divides the shape into many parts.
An improper fraction is a fraction where the numerator is larger than the denominator. A proper fraction is a fraction where the numerator is less than the denominator.
Fraction as a concept is introduced in grade 4, where students learn various things like identifying common fractions like half, 1/4, 1/3, 2/3, etc. They also learn identifying symbols like 1/2, 1/4 and explaining their meaning and even equivalence of fractions.
C. Confident.
Yeah.
Why?
Because 7 is the total and 2 are buses, and the question is how many are buses out of the total vehicles? 2/7 because there are 7 vehicles and 2 of them are buses, so it's 2/7.
Okay.
So I say the answer is 2/7 because there are 2 buses and the total number of vehicles are 7.
Total number of vehicles is 7. Okay.
What fraction of the children in the following group are girls? So the answer is 5/2.
Tell me why.
No, 2/5.
Tell me why.
Because there are 5 children in total and they are asking how many of them are girls. So that's why we have to take the girls out. I explained for 5.
Okay, fine.
The girls are 2 and the total boys and girls are total of 5. So 2/5 is the answer.
Okay.
The 2 questions that we saw tested the basic idea of fractions, the idea of parts, whole, and representing the number as a fraction. Most of the students were able to answer that. But can we say that they've understood the underlying concept of fractional parts being equal shares or equal divisions of a whole? To understand this, we asked another question where an object was divided into unequal parts and we asked them what fraction did one part represent. I have a pizza divided into 4 parts. Okay, I give 1 part to Saundipya, 1 part to Yamit Kumar, 1 to Arun and 1 to Praveen. So my question is, what part will you all receive? What will be the fraction of the pizza that you will receive?
1/4.
1/4. Why are you saying 1/4?
Because it's 1 piece on 4.
Okay, so there are 4
I've got 1 piece on 4 pieces.
Oh.
Students say that fractions are parts of a whole and it seems that they are fairly clear what a whole means. But the idea of a unit or a whole and its subdivision into equal parts is the main concept which is fundamental to fractions and even decimals for that matter. But it seems to be missing in class 4 students. It might be possible that it's difficult for class 4 students. But what about class 6 students who by now would have advanced to far advanced concepts as far as fractional numbers are concerned?
Because it is divided into 4 parts and I get only 1 part.
Okay, it's divided into 4 parts and you get
1
part. So the fraction of pizza that you will get is
1/4. gets 1/4 only because the pizza is has cut into 4 parts, not equal, 4 parts. So they will get 1 part each. They can't get equal.
Okay, so whether irrespective of whether the parts are equal or not, it has to be 1/4.
Yes.
Is it?
Yes.
See that it's not equal, but we are talking about the pieces divided. So the pieces divided are 4, and out of them I am getting 1.
Okay, so like he's saying that total pieces are 4 and I am getting 1. So whether they are equal or not, I will say 1/4. Is it?
Yeah, but it also matters about the equal.
Okay, it matters whether it's equal or not. But will we call it 1/4 or not?
Yeah.
Okay.
So what portion of the pizza did Anjali get?
I got 1/3.
You got 1/3. How much did Chinmay and Smaya get?
They also got 1/3.
So what fraction of pizza did Ved receive? Ved, what fraction of pizza did you receive?
1/3.
What about Abhinav?
Because the pizza is divided into 3 parts, I got 1/3, Ved got 1/3 and Rukmani got 1/3. Each got 1 slice out of the 3 pieces.
Okay.
So this will be each receive 1/3 of the pizza.
Because we have divided pizza into 3 parts and you got 1 piece, so you are saying you got
1/3 of
1/3. Okay. The same students who are able to answer that question on vehicles or boys and girls are not able to answer the question on pizza. So why could that be? One reason which we think could be that they've developed a very superficial understanding of fractions as number of parts that are asked upon a whole. In case of vehicles, we aren't bothered about the size of the vehicle, since we are considering each vehicle as a single unit. Similarly, in case of boys and girls, each child is a single unit. And so even if the students apply their algorithmic understanding of number of parts asked upon a whole, they will end up getting the correct answer.
They only know that fraction means it's a part of something which has been divided, but the emphasis on the equal parts, that is whatever parts are there, that is to be equally divided, that is what is lacking. It is, as you know, we are using blackboard or the whiteboard, and normally when we draw circles and when we divide them into parts, it's not very exactly the equal part. So what the child perceives, he is looking at a figure, the teacher is saying that it is, it is equal, but the child is not getting it.
Okay.
That visualization is not there. And if so, it is better that we deal with things which are concrete in the sense, like wherein the error, we can avoid that error. If I will also draw a circle and then represent, I cannot draw to the size on the board. Whereas on a piece of paper, I can, to the size I can draw and I can show it to them. I think that one thing could be there, that children have not been, in some cases, though they are emphasizing the fact that the parts are equal, but visually the children don't get it. I draw 2 circles. I draw the exact half, and I draw another circle wherein it is also divided into 2 equal parts. It's not exactly equal. When I show both of them visually, then the child is able to understand that this is called 1/2. This figure is representing 1/2, and this figure isn't representing 1/2. Why? Because the 2 parts are not equal. So those kind of examples, when they are dealt with in the class, I think this misconception should not arise.
So the picture there is somewhat like this.
Okay.
So if I take this measurement
Okay.
and cut it into this, it comes as 4. 1, 2,
Okay.
3 and 4.
Okay.
And the same thing if I do 1, 2, 3 and 4, it
Okay.
comes as 10.
Okay.
So if I take only so much, it's 4 by 10.
What we saw in the student responses over the last few minutes was that students have certain mental models, ways of thinking about the world, certain ideas, and clearly these ideas are not what we intended to pass on to them as teachers or interested adults. These are ideas children have found by actively trying to make sense of what they are seeing around them or what has been taught. What is however important to understand here is that the instinctual reaction of adults or teachers when they see these kind of responses is to say that let me explain this again, let me explain this more clearly, 2 times if not thrice. This is bound to fail. So what we find is that it's extremely important for a teacher to listen first, find out what is already on the child's mind, to then help the child to review the correctness of this idea, weigh it against other ways of thinking, other mental models, to really be able to say that no, this didn't work and this is a better way of looking at things. And our hope is that teachers start doing this based on seeing films like this. You have seen just one concept, but there are several such ideas across class levels, across topics. And this is our hope that teachers will become active listeners and we will have a chance to teach our children better.